Welcome to our final hands-on project where we will introduce you with the components of our LFR and will show the Arduino code, and finally we will show you the comparison between LFR with and without PID.
I am going to describe about the components that we have used in our project. We used L298N as our motor driver and PVC sheet board as our car's chassis. We used 5-volt yellow motor and controlled them via our driver. And as a microcontroller, we used Arduino Uno. We used 5-array IR sensor to sense black and white color and so that it identify the line. It sends data to Uno and Uno commands motor driver to run accordingly by calculating the PID. Furthermore, to run the motor driver we used two 3.7 lithium ion battery, and to run Arduino Uno we used 9-volt battery.
Now we will see the Arduino code of our LFR with PID. We have taken some variables for our driver and our sensor, and we have connected the pins of our driver and sensor with the Arduino pins which we have mentioned here. And we have taken 5 variables for our IR sensor, as our IR sensor is of 5 arrays. And here we can see in our setup, here the Arduino is working as an output and input for motor driver and IR sensor respectively. And next we will call the PID function. If we go to the PID function, we will see that we will cal calculate the error by calling the calculate position method. Uh, in our calculate position method, our IR sensor is taking 5 inputs, and according to the combination of the inputs, it will return some value of the error. We have taken this combination from this research gate, and if we see this combination, the main difference with this combination and ours is they have taken 1 as the black tape input, and we have taken 0 for the black tape input. Now, after returning the error, it will check if the error is 100, which will cause only when the LFR is not on the black path. It will stop the LFR. Otherwise, it will calculate the error sum, and with the PDI formula, it will calculate the motor speed, and with the motor speed, it will calculate the right motor speed and left motor speed. We also have used constraints so that the value of the speed does not go below 0 and does not go beyond 255. And we have taken some conditions for left-right rotation. And if we see here, when the left motor will go backward and right motor will go forward, it will go strong left. And when the left motor will go forward and right motor will go backward, it will go to strong right. Otherwise, it will go forward with the value of left motor forward and right motor forward, which we have used where we have used high for the input 1 and input 3 pins. And with the enable pin, we can control the speed of the left motor and right motor. And here we have used some test cases to test our outputs. If we see our output of this PID, we can see according to the value of the error, the right motor speed and left motor speed is increasing and decreasing accordingly.
Now we will see a comparison between LFR with and without PID. In normal LFR, it can get out of the track. Also, it can oscillate while traverse. Again, the movement of the robot will not be smooth without the PID algorithm. LFR with PID algorithm, it will provide a smooth movement of the robot. Again, moving throughout the intersecting path, it moves very smoothly. Now we will see a comparison video between LFR and LFR with and without PID. In the LFR with PID video, we can see it tends to keep the black path middle of the IR sensor, while LFR without PID, it's not keeping the black path middle of the IR sensor. There might be a possibility to get out of the track. Here in the intersecting point, the LFR with PID, it moves very smoothly. But LFR without PID in the intersecting path, it's not moving smoothly, and there might be an oscillation while moving. Here we can see LFR without PID, it's not keeping the black path middle of the sensor. On the other hand, LFR with PID, it's keeping the black path middle of the IR sensor and moving very smoothly. In the LFR with PID video, we can see it tends to keep the black. Here we also put a camera with PID LFR to see as a first person view. By using this, we can see the path environment more closely.